Okay, we are going to get started now. Now that we've taken our little detour there. We're going to come to section 5. We're going to talk more about transformations of functions. On your guys' quiz and like on the review, there was a problem that talked about transformations. It was like the one with the square root graph. You had like I'm just going to write it up here on the board. Yeah, you had like something like this, and then the other one would say something like this, maybe. Okay, and this number here is what we look at when we're talking about the transformation, because that's going to cause the graph to move around. So that's what we're going to focus on a little bit today. To do that, though, I want to talk about graphs of common functions. These would also be known as parent graphs, which you guys have talked about parent graphs in other classes before, but parent graphs would be like the original graph, so the thing that you started out with. And then when you start to move graphs around, that's when they no longer become the parent. They become transformations of the parent graph. So your graph, when you graphed like your square roots, you probably saw yesterday in your quiz that they looked the same because they both like went up and like make an arc like that. This one does the exact same thing. It was just in a different location. Okay, so I'm going to go through these and kind of show you some key points. That way, going forward, when you start to have to do the transformations yourself, you know what the line should look like, and then you know kind of what some points you should be putting on there. So we're going to start with this first one, which is just a line. F of x equals x. Remember, f of x means y, so that's really like y equals x. This is just a line. It goes through the origin. So it goes through 0, 0, and it has a slope of 1 over 1, which means it goes up 1 over 1 forever. Or you could go down 1 and left 1. But that's what your line is going to look like. You've probably graphed 100 lines in your lifetime. But when you talk about the parent graph, that's kind of where it started. Now, when you start to change the slope, you start to add on a y-intercept. That's going to start to shift that graph up and down, could possibly have it flip directions. The other thing that they're also going to be really focusing on in this section is how to describe the graph as far as like its domain, its range, and where it's increasing or decreasing, and going back to that even odd stuff. But the even and odd is going to be mainly looking at the graph and being able to decide what kind of symmetry we think it has. Remember that your domain would be your x values. So let's go put a little x in front of domain. Range would be what your y values are doing. And then increase, decrease, that would be, is the graph going up? Is it going down? Like, how is it behaving? And then even odd would be, does it have any symmetry? So remember, even graphs have symmetry along the y-axis. So if you use the y-axis as the line that cuts through the graph and it's equal on both sides, that's an even symmetry. If it's symmetric to the origin, so the origin's kind of the spot where it reflects, that would be odd. If we look at this one, for your domain, any x value works because you can go all the way to the left on the x values or all the way to the right, and you're going to be able to plug it in and get a number. So my domain for this one is just going to be negative infinity to positive infinity. Your range would be your y values. So that would be like how low can the graph go and how high can the graph go. It can also go from negative infinity to positive infinity, because I can continue to just add more and more points. If you guys look at this graph for increasing and decreasing, remember we read graphs left to right. So if you start at like the far left that I have and you go to the right, is it increasing or decreasing? It's increasing, it's going up, and it's doing that forever. So again, we're going to say increasing, so I'm just going to use an I for that, and I'm going to say it's increasing from negative infinity to positive infinity, because that line is always going to go up. Now, if I had a negative in front of my x, that would be a negative slope. It's going to cause the graph to go down forever. And so then we would switch it. It would be going decreasing from negative infinity to infinity. And then even or odd. Well, it's not even, because if I draw a line or if I imagine the y-axis cutting that graph in half, it's not symmetric on both sides of the y-axis. But if I imagine folding it along 0, 0, like almost imagine if there was a diagonal line right here, and I were to fold that line along that diagonal line, it would be symmetric there. So this would be considered an odd graph. Okay, That's really basic. That's like your original line equation. Like I said, you've probably talked about the line equation a lot when you were in algebra, even in algebra 2. But now we're going to start getting into some of these other parent functions. So starting with the next one, which is x squared. What do these graphs look like? Yeah, okay? They're always your parabola shape. So some key points for your parabola is vertex is always at 0, 0 for the parent graph. And then you have matching points on either side. So you have one at 1, 1 and negative 1, 1. And then you also have some at 2, 4 and negative 2, 4. Those come from the parent. Like if you typed into a graphing website or even on the tables on our calculators in here, if you typed in that y equals x squared, these are the numbers that are going to show up in your table in order for you to graph it. But you're going to get this parabola shape. And we could add more. We could add 3, 9 if we wanted to, and negative 3, 9, because those would all be points that would show up on our table. You don't need to have a whole bunch of points to graph your parabola. You just need to know kind of the general idea of what it looks like. Okay, so now let's talk about the domain and the range and all of that for this one. So remember, domain would be your x values. So again, it looks like I can put anything in for x. I could put in negative numbers, I can put in positive numbers, and I can evaluate those at x squared. So my domain is going to be negative to positive infinity. Let's talk about the range though. Range is your y values. What's the lowest y value that we see for this graph? 0. And what's the tallest? Well, 9 for here, but could I add more? Yeah, so we would say infinity. So that range is a little different because of it having that hard stop there at the origin. Okay, increase and decrease. Again, read your graph left to right. So if you start on that top left corner, what's it doing? Top left corner. Decreasing. And then what happens at the origin? It starts to increase. So it actually does two things here. We need to state that. So it decreases from negative infinity to 0, and it increases from 0 to positive infinity. Do you think this is an even or an odd graph? Even, because that y-axis is cutting that graph in half. Okay, next to this, it's your cubic function. Do you guys know what a cubic function looks like? Yeah, it's kind of like an S shape almost, or like a kind of like a squiggly line. I don't know how to describe it. It's kind of like a parabola, but it's like half of it's going up and half of it's going down. Okay, so some key points for a cubic function. And again, if you really wanted to get a table of values, you don't have to memorize these. You can always plug it in to a calculator and get your original set of points by just typing in x to the third. But again, you're going to have a point at 0, 0. If I put 1 in for x to the third, that would be 1. So I have a point at 1, 1. If I put in a negative 1, it would be down at negative 1 because it's raised to an odd power. So it's going to cause that shift. If I put in a 2, I would be up at 8. And if I put in a negative 2, it'd be down at negative 8. All right. What do you think the domain would be here? Can you put in negatives and positives for x? Yeah. So again, we're going to go from negative infinity to positive infinity. What would be our range? Same thing. There's no limit this time on the y values because we have half the graph is going down, half the graph is going up. Okay, read the graph from left to right. Is it increasing, decreasing, doing both? Increasing? Okay. Do you think this is an even or an odd graph? Does it appear at the origin that the graph kind of reflects? It does reflect. It's a little odd to, like, I can't necessarily just draw a line like I did on that linear one to show you guys the reflection, but it does almost look like that top side has corresponding parts on the bottom side. They're just all negative. So this would be considered an odd graph with respect to the origin. Now, if I start transforming these graphs and I start moving them around, then it might switch it from not being odd anymore because it has to kind of be reflective around that origin part. All right, those are your first three. Are we feeling okay about those? Okay, so we've got a couple more that we're going to get into now. The next one is your absolute value graph. What do these look like? They're still linear, but they make a V shape. Okay, so we have points at 0, 0, and then they go up 1 on each side, but it stays positive, so it makes that V. Okay, again, because when you're putting in numbers for your x, since its absolute value is going to force it to become positive, that's why it does the V shape there. What would we say for the domain? Yep, there's no restriction on the x. We can put in whatever we want. How about for your range? Good, 0 to positive infinity. Again, it looks like we have a hard stop there at the origin, but it's going up on both sides. Increasing, decreasing, both. So how would we describe, like if we're reading it left to right, what's it doing at first? Okay, so it's decreasing from negative infinity to 0, and then it's increasing from 0 to infinity. Even or odd? Even. Okay, this next one is the square root function. And notice how it's right underneath the quadratic, because they're kind of opposites of each other. So when you have something squared, if you square root it, that's like undoing the squared. We saw some of these in our review on the quiz that we took yesterday. So I want to graph this. So if we look at our square root function, it's going to stay positive. So it's going to start at 0, 0. 1, 1 would be another point because you would square root these numbers. Then I try to focus on just like normal numbers that I can square root nicely. Like 4, if I square root 4, I get 2. If I square root 9, I get 3. There are other points in there. They just aren't going to be super nice numbers because you're square rooting things like 3, 5, 6, 7, 8. Still a thing, isn't it? Okay, so all of those numbers would be on there, but they're not going to be super nice, clean numbers. So I'm going to connect that. Now, something I want you guys to understand, because this is the part of the graph that we don't see. Remember I said that this graph is the opposite of the parabola that we saw up above. But a parabola had two sides to it. The square root is almost like half of a parabola. If we're being really technical, there is actually another half to the parabola down here. We're not going to focus on it for right now, but in like other math classes you guys might find yourself in when you guys go off to college or even next year, you might see that where they talk about the square root function because they're thinking about what would happen if I thought about the square root of like plus and negative roots. Because if I square root 4, I could have had positive 2 or negative 2 as an answer. Most of the time we don't see the negative side reflected or shown, but it is there. And so you can kind of now see this is very similar to that parabola that we had right above it. But just focusing on the red line that I drew, what would be your domain? What are the x values that appears to be on my graph? 0 to positive infinity. Why do you guys think I can't do a negative x? You can't square root a negative x. Because if you square root negative numbers, what happens? It doesn't become positive, but what comes out when you have square roots of negatives? I. Are I real? No, they're imaginary. Okay, so if they're not real, we can't reflect them on a graph because they don't actually exist on the graph. Okay, so that's why we have to say 0 because we can't put in negative numbers. Okay, how about your range? What are your y values doing? 0. Don't the y values go up? Yeah. Because your y values also start at 0, because 0, 0, but then it's going up because like my x was 4 and my y was a 2. My x was 9, my y was a 3. So it's continuing to increase. Is your graph increasing or decreasing? And how would we write that? It's increasing from where? Good, 0 to positive infinity. Even or odd? It's not odd, actually. It's not even either. It's neither. What'd you say? Oh, it can't be both. It can only be one or the other, or neither. Why is it neither? So if I drew a line here, it's not reflecting on the other side of that line, so it's not even. And if it was going to be around the origin, there would have to be a part like here, and there isn't. I talked about where the other half of the graph is, but it's all facing the other direction. So it's not reflective across the y-axis. It's not reflecting across the origin. So it is neither type of graph. Okay, we've got one more parent to talk about. This is the cube root function, opposite of the cubed function that we had right above it. Okay, that's why I kind of stacked them like that, so you can kind of see their similarities. So we're going to have a point. If I put 0 in, the cube root of 0 is 0. If I put a 1 in, the cube root of 1 is 1, but I could also put in a negative 1 and get negative 1. You can take the odd root of a negative number because we could raise something to an odd number of times, like an odd power, and get a negative answer. Okay, and then I'm going to kind of fill in some other points here for you. So another one that you could put in would be the cube root of 8. The cube root of 8 is 2. The cube root of negative 8 is negative 2. Again, I'm only focusing on numbers that are easy for me to do this operation to. Again, there are other numbers in there that we could cube root, but they would be decimals that would show up on your graph. And then when I graph this one and I connect it, it still kind of has like that S shape that the cubic function did up above, but it's kind of facing a different direction. What's your domain? Good. Range? Same thing. Is this graph increasing or decreasing? Increasing forever? Yeah. Odd or even? Odd. Kind of a lot of information there on just that front page. Yes, there's more. We're not going to get through everything today. Yeah, we're not going to get through everything today. I also wasted time with our story time, so.
We're not getting
Okay. So I want to make sure you guys have all this information written down. I think this is probably where we're going to stop for today. But tomorrow on the next page, this is when we're going to start getting into these transformations. How to read a graph to know, is it going left, right, up, down, like what's happening. Okay?